and I'll leave the word to you now, Stefan, if you're ready.
Yes. There we go. Hi, my name is Stefan. I work at Trifork, not in this office. I work in the Aarhus office, so I came a long way as well, like you other guys. On a daily basis, I work as an iOS engineer, but also as an ML engineer. And I'm here today to present some of the projects that we're currently working on and some of the common pitfalls and some of the learnings that you should bring home with you today. So the agenda, just a quick warm-up. It's really good not to kind of get burned out. Then the common pain points, both from a business perspective, but also from an engineering perspective. Then the process that we apply here at Trifork and with some of the current projects that we're using this process, and remaining the key takeaways for this presentation. So, just a quick warm-up. A lot of you, some of you, 20% were using machine learning already. Hopefully you have a good idea, especially after Danny's lovely presentation, that what is machine learning. But you know, on a very, very high level, it's something about where you take data and you put it through an algorithm and you end up with a model. This is as technical as I'm going to go in this presentation, so hopefully if you can follow along with this, it's going to be great. I'd love, if you stick around afterwards, I'd love to stay and talk technicalities with you and which algorithms we use and all that, but then we take that afterwards. So let's go straight to the pain points. There are 4 that I actually like to highlight today. The first one is image recognition of complex objects. And that's because image recognition is such a common task and a lot of you can probably make use of it, which is why I'd quickly like to review it. Second one is when you have imbalanced data set. Third one is related to human bias, and the fourth one is where to start. So let's dig in. Recognizing complex objects. The most complex object in the world is probably a banana. I can never recognize it. I know. Let's just see. I have, since I'm an iOS developer, I made a little app from home, you know, like the TV chefs. So let's just see. I'm gonna put it up here. Do I drag it? Yeah. So you can see my screen here. I have my little app. And I have a banana. Glad you didn't need it all. And when I use this, it says that it's a banana with 99% accuracy. So it's pretty good. Now, I have an apple as well. Let's just see. And let's see. It says it's a Granny Smith with 80% accuracy. It's not very common. Some of you maybe know what a Granny Smith is, but I'm going to show you now as well. Here. Wow, this dual screen. So yeah, this is my backup banana in case you ate it all, and backup apple. This is a kind of a pre-trained ready model that I found online and just embedded in my iOS app. And it's used for recognizing approximately 1,000 common objects, household objects. And when you look through this list, you're going to see that banana actually exists in this list. And you're also going to see that Granny Smith appears in this list. But the word apple does not exist in the list. And that's why it cannot tell me that this is an apple. But it's not completely wrong, because Granny Smith is this kind of apple. It's a green apple. So I can just try it again. Opa, I have it here. Can you see? Ah, yeah, you can. Unless I use photo. And you can see now it increased to 85%. So the point of this is that if you want to do some sort of learning with this, with image recognition, you need the right kind of data and the right labels. So if you want to recognize an apple, you need to have some data that tells you this is an apple. When you look through the list of those 1,000 common objects, you're going to find approximately 30 different breeds of dogs. I don't know, I guess they're dog lovers, whoever made that data. You're going to find this Norfolk Terrier, and you're also going to find this Norwich Terrier. I'm a dog person, I like dogs, but I'm not a dog expert. And to me, these 2 dogs is the same dog. You know, this one has a bit of wax in it, you know, hair dried. I cannot tell the difference. But when you use the machine learning algorithm, it can tell the difference. And the rule of thumb is that if there's an expert out there in the world who can tell the difference, then a machine learning model can learn this difference as well. So they've been asking a lot of dog experts to categorize this data, to label it, and in that way, you can teach the algorithm. So if you have some complex object you want to recognize in your own company, that's the rule of thumb you can go with. So the second common issue is when you have imbalanced data set. And what I mean by that is if you have data where it's like 50% of what you're interested in, like 50% male, 50% female, it's nice, it's stable, it works. But most of the time you're going to have data like this, where, for example, this is from genomes, where you have 90% of the normal genes and 10% of the gene that you don't like, which is the odd gene out. This is often a bit hard to explain why it's a bad thing. So normally, I use this example. It's an app called Not Hot Dog, which is a real app on the US App Store, and it's going to inform you whether your food is a hot dog or not. It's a super useful app. I use it every day. I use it for breakfast. And it was created as a marketing stunt for HBO for their Silicon Valley series. And I'm not kidding you, it is a real app. Let's just get this up here again. I have a hot dog here. I couldn't bring a hot dog from home, I'm sorry. So let's just see here. I have the app here. And it's a hot dog. It's so good. And then if I take off something else, it's not a hot dog. So it's not just random, it's actually recognizing something. So when they made this app, they had a data set of 150,000 images. But only 3,000 of those images were hot dogs, you know, the thing that they actually cared about. So it's a classic example of an imbalanced data set. When you use machine learning, it's kind of like a child, you know. It's gonna learn the easy thing first. So if you use a machine learning just out of the box on this, it's gonna learn that if it says that everything is not a hot dog, it's gonna get an accuracy of 98%, which is a really good score. But it's saying everything is not a hot dog, so it's a useless model. You cannot use it for anything. And the key takeaway for you guys is that just because somebody comes and presents a machine learning algorithm that says we have an accuracy of 99%, you need to take it with a gram of salt, take a step back and actually make sure, is it doing what it's really in your best interest? The third case is human bias. I like using examples, and there's another example I'd like to use today, which is called Quick Draw from Google. It's a website, it's a small game, where you can draw, and then a machine learning algorithm is going to try to predict what you're drawing. So let's just see, I have it here. I gotta drag it in. Oh, there we go. So let's draw. I think the speakers are on, it might be a bit loud. Hopefully. So let's see. A barn. Okay.
I see lion, or cooler, or fence, or bread, or oven. I see or camel, or I see microwave, or cupcake. Oh, I know.
Hey, there we go. Shit. Thank you. I know. Okay, let's just try another one.
I see arrow, or music note. Oh, I know.
It's tooth. It's so good, I know. I practiced all weekend just for this. Should I try? I don't know. Okay. Okay.
I see diving board, or hot tub, or pants, or hourglass. I see tiger.
You know, it's Noah's Ark. Can you
I see pen, or telephone, or computer.
It's literally just Anna! Okay, let's see.
I see nail, or squiggle. Oh, I know. It's animal migration.
So, first of all, it shows you how unpredictable a machine learning model can be. But an interesting thing is that this is a website and it's a game that they could bring out to the whole world at the same time. And they quickly realized that, for example, if they asked people to draw a cat, it would be pretty much the same all over the world. They would kind of draw a circle with two eyes and whiskers and nose and all that. But that was actually the only thing that people knew how to draw the same. If they asked anything else, everybody drew it differently. So, when they asked, for example, to draw a shoe, a lot of people drew sneakers, but a few people, they actually drew high heels. And there's nothing wrong with this. High heels are shoes. But the machine learning algorithm learned to kind of prefer sneakers as a real shoe and not high heels. It couldn't identify it. And that's simply because it got too much of the sneakers data. So it's kind of related to the previous data of Inbalance Data set. But in this case, you don't know it for sure because it's kind of embedded in the real data you have. If you look at the hot dog example again, this app is super good at recognizing kind of plain hot dogs. But for example, this exotic French hot dog that we have here in Denmark, it doesn't classify it as a hot dog. It doesn't think it's a hot dog. And it's the same with these kind of gourmet hot dogs with a lot of sprinkles on top and extra flavors. And you're probably sitting and thinking, okay, cute example, it's hot dogs, right? But this can actually kind of escalate. If you think of self-driving cars, for example, they've been driving all over in the United States and they're going to start driving soon. But you can't just take it to another country, right? Like, if you bring it to Denmark, how is it going to deal with this army of bicycles? Or if it goes to the Autobahn, how is it going to handle the speed limits? Like, okay, there's no speed limit. Should I go to the max? Or should I kind of keep an average? Or, what should I do? So it's a very simple example, but, it can really populate to a lot of different areas. So, where to start? It can be really hard to start. There's a lot of algorithms, there's a lot of platforms, there's a lot of ways to approach this. But just like Danny showed, we think this kind of iterative approach where you kind of, you have a few ideas like, okay, I want to try this data with this algorithm, see where it goes, where you have this loop all the time where you learn and where you iterate. That's the way to go. Because machine learning is still a black box for some people. And sometimes if you make an experiment and you learn, oh, that was not the way to go, it's still a lesson learned. It makes you smarter. You know where to go next. Normally, we actually recommend that you kind of start out with these kind of machine learning as a service that Danny also mentioned. There's all the big players like Google and Amazon and Microsoft. And they're really good because it's these kind of out-of-the-box solutions where you pay per usage. Then once you've learned your lessons, you know what data you use, you know what algorithms to use, you can kind of go over and start using more open source because this can create custom models for your use case specifically and give the best results. The downside to this is that you often need employees or people who can work with all of these open source tools. And when you look at it as a whole, there's kind of this whole range of possibilities that you can use from ready-to-use APIs in this cloud to just custom model from scratch over here. And this kind of leads me to the Trifork machine learning process as well, where we often have these loops, where we go out to our customers and say, okay, let's just take one iteration and see where we learn. And then in a month from now, we know more. And the reason why we do this is because we think this will reduce the risk for implementing custom models for the unique use cases in the companies. Because it's easy to use these off-the-shelf products, but often they're not good enough. For example, the hot dog app, right? They actually started out using one of those machine learning as a service. And they uploaded the image to them and it classified. But they realized it was really bad at recognizing hot dogs. They were really good at recognizing cups or apples or fruits. But they quickly realized they needed to move towards the right end of the scale to use custom models. When we make these iterations, we often use approximately 100 man-hours, but spread out over a calendar month. The reason for this is because you kind of need time to reflect about the data. You need to reflect about the lessons learned, but also because the computer actually needs to train. And some of the potential outcomes can often be that you want more data gathering, or you want to refine your algorithm, or maybe you just want to put it into production. So we actually have this process ongoing with the different customers right now. So I'd like to kind of briefly give an overview of some of the projects that we have. The first one is a report classification problem that we're doing with bank data. Bank data is the backend as a bank, you could say. They're the infrastructure for many of the big banks here in Denmark, like Jyske Bank, Sydbank, and so on. Their case was that the bank employees often need to classify public data, public reports, which sometimes are 4 pages long and sometimes 30. And it's very tiresome and trivial to go through this. So the pain were quite obvious. Like they had a pain that, you know, they were wasting a lot of time reading these trivial reports. And the potential gain of this, if we used machine learning, was to free up resources for the individual employees so they could become more efficient. Another project we're working on is error detection, where we're working together with a production company that has several production facilities around Europe that are running 24/7, and they're using SAP as their ERP. And the case study is that often a salesperson enters an order into the SAP system, which converts it to the system file for the construction robots. The problem is, sometimes there's an error in this order. Sometimes they're error prone, and it halts their production line for hours, which is a lot of waste of money and time. So we want to use machine learning to identify potential errors upfront, and then reduce the downtime for the production facilities. A third case we're working on is a company that's currently B2B and sells add-ons to certain products in the household. They want to be more B2C, and they want to achieve this through a mobile app with image classification. So the end user should be able to take the app at home and take images of the house to identify what products they already have. The pain is that the end user has a hard time classifying these products, so they want to ease it up with image recognition. And the big gain would be that the company knows exactly what to offer, and they also can achieve an upsell because there's an app directly in the end customer's hand. So, the key takeaways from this presentation is there's a lot of experiences out there in the world already, and you should avoid making similar experiences, for example, to human bias or Inbalance Data set. You should also take this iterative approach to reduce the risk. So you shouldn't go out and take a whole waterfall and say, we're going to use this next 6 months of doing machine learning. No. You should take small iteration and learn and say, is this the right way or is this the right way? And we definitely recommend just start with simple data and simple algorithms and build on top of there. If any of you ever comes to Aarhus, feel free to contact me and write me. I'd love to grab a coffee. But otherwise, thank you for now.